Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have x factorial equals to x cubed minus x, and we will solve this problem for the values of x. So here in this question I will solve this by using recursive method, or you first know about factorial. If we have n factorial, then we will open this n factorial as we just decrease 1 on each term, and you get, if you have n, when we decrease minus 1 you get n minus 1, when you decrease 1 here then you get n minus 2, when you decrease here then you get n minus 3, and up to so on you will get 3 2 1. Similarly, if I can break this process at any step, then you will write the factorial sign. It's mean, if I can open this factorial at up to the 3 terms, then you get, this is the first term, n minus 1 be the second term, n minus 2 be the third term. So if I can break this process here, then you just write the factorial sign. Similarly, when you open this factorial up to the 2 terms, then you get n into n minus 1 factorial. Okay, I think so you remember this concept, and now we will move toward the solution of this problem. So now first I can open the factorial of x, and you will write here the x factorial up to the 3 terms. I can open this factorial up to 3 terms like this. So you get here x factorial equals to x cubed, and now I can take common x here, then you get x times of x square minus 1, and we write this one as 1 square. Now you can just open the factorial of x, and you will get here x times of x minus 1 into x minus 2 and its whole factorial, and this is equals to x into x square minus 1 square, and here you just use the nice square identity, which is a squared minus b squared equals to a minus b times of a plus b. So now we use this nice formula in the right hand side of this question. So you will get here x minus 1 times of x plus 1. So now you will focus on both of the sides, and you see that this x and this x are gone, and x minus 1 and x minus 1 are gone, and here we obtain x minus 2 factorial equals to x plus 1, and we will again make little bit simplifications here, and we write our right hand side as, so this is our right hand side, and we will write x plus 1 as x minus 2 and plus 3. We break this one and we write minus 2 plus 3, and here you have x minus 2 and plus 3. So in the left hand side you have x minus 2 factorial. So now in the next step we will convert this nice equation into the simplified form. So in order to convert this into the simplified form, we need to make some substitutions here. So now I can take y equals to x minus 2. So when you put y equals x minus 2 on the both of the sides, then you will obtain y factorial equals to y plus 3. So this will becomes in simplified form. So now in the next step we will again open the factorial of y, and you get here y into y minus 1 factorial. I can break this factorial up to 1 terms or up to 2 terms. You will get here. And we move this y in the left hand side and it is equals to 3. So now you will focus on the both of the terms and you see that we have y with a common term. So we divide each term by y on both of the sides in this form, and you will obtain these are cancelled by each other, these are also cancelled by each other, and we obtain in the left hand side is y minus 1 factorial equals to, sorry, this is minus 1 equals to 3 over y. And now we move this minus 1 in the right hand side and you will obtain y minus 1 factorial equals to 3 over y plus 1. So now I can first again write this expression as y minus 1 factorial equals to 3 over y plus 1. So now we will find the value of y here by inspection. So now we put the values of y and we check that which values are satisfied here. So that first I can take y equals to 1. So when you put y equals to 1 on both of the sides, then you will get in the left hand side we have 0 factorial equals to 3 over 1 is 3 plus 1, and you know that 0 factorial will be equals to 1 and 3 plus 1 equals to 4, and you just conclude here that 1 is not equals to 4. It is not equals to 4, so it is not possible. And now we check at y equals to 2. So when you substitute y equals to 2 in the given equation, then you will obtain 2 minus 1 is 1 factorial equals to 3 over 2 plus 1, and you know that 1 factorial equals to 1 and 3 over 2 equals to 1.5 plus 1, and it is equals to 2.5. so it is again 1 is not equals to 2.5, and this case is again not possible. And now we will check at y equals to 3. So when you put y equals to 3 in the given equation, then we obtain 3 minus 1 factorial equals to 3 over 3 plus 1. And you see here 3 minus 1 equals to 2 factorial, and these are cancelled by each other and we have 1 plus 1. And you know that 2 factorial equals to 2 and 1 plus 1 is equals to 2. So this shows that y equals to 3 satisfy the above relation or this relation. So this shows that y equals to 2 be the solution of given problem. So now we just take the solution is y equals to 3, and now we back substitute the value of y, and in the start of the problem we will take here y equals x minus 2. So x minus 2 equals 3, and you get x equals to 3 plus 2, and we have x equals to 5. So x equals to 5 be the solution of the given problem. And now we will check this solution. Is x equals to 5 satisfies the given question statement or not? So our given question is x factorial equals to x cubed minus x, and now you put x equals to 5 and you get 5 factorial equals to 5 cubed minus 5, and you open this 5 factorial as 5 times of 4 times of 3 times of 2 times of 1, and you know that 5 cubed equals to 125 minus 5, and when you multiply all these terms here, then you get 120, and in the right hand side you get 120. So this shows that x equals to 5 satisfies the given question statement. And finally we conclude that x equals to 5 is the solution of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.